Good morning, everyone. Today we are going to learn the new chapter on energy changes. So, the lesson objectives, there are a few points specifically mentioned in your IGCSE syllabus. You should be able to describe the meaning of exothermic and endothermic reactions. Interpret the energy level diagram showing exothermic and endothermic reaction. Describe bond breaking as endothermic and bond formation as exothermic reaction. Then you should be able to draw and label the energy level diagram. Then calculation that involves bond energies, different types of fuels like hydrogen, uranium, etc. So these are the main objectives to be covered under this topic. So let us divide the topic into 6 lessons and then accordingly we will proceed. So as an introduction to this chapter, we had seen what are the different types of chemical reactions. So probably you might have studied in lower classes different types of reactions such as synthesis reaction or combination. You can also find decomposition reaction. Let us see one by one what are the different types of chemical reactions. So in the first lesson, we just covered two objectives. What are the different types of chemical reactions? How will you differentiate between exothermic and endothermic reactions? So now see, the first type of reaction is a combination reaction where you can find two or more reactants combining together to form a single product, like hydrogen and chlorine forming hydrogen chloride, hydrogen and oxygen forming water. If you go with the decomposition reactions, you can find one reactant is broken down to many products. Right, so that means it is exactly opposite to the combination reactions. So for decomposition reaction to happen, you have to provide some energy. So if you are providing heat energy, it becomes thermal decomposition. If you are providing light energy, it is photolysis. If you provide electricity, that is electrolysis. That's what we studied in the previous topic. Right? We had seen sodium chloride molten. You are passing electricity, it is broken down to sodium and chlorine. The very same thing. So electrolysis is also found to be a decomposition reaction. Then afterwards, another type of reaction is single displacement reaction. You can find a more reactive metal or a more reactive non-metal, right, that undergoes this displacement reaction. We had covered the same topic under the reactions of halogens. We had seen a more reactive halogen displaces less reactive halogen from its solution. Then afterwards, we had moved to the next reaction, double displacement reaction. Here, AB plus CD, you are getting AC plus BD. That means there is an interchange of ions taking place. Okay, exchange of ions. There are two types of double displacement reaction. One is precipitation and the other one is neutralization. Once you once you are mixing two solutions like sodium chloride and silver nitrate, if you are getting an insoluble solid, after the reaction, you call that reaction as precipitation, and the insoluble solid is found to be the precipitate. Then neutralization reaction, probably you might be familiar, that's the reaction between an acid as well as a base. Then another type of reaction is combustion, right, where a hydrocarbon reacts with or burns in oxygen to produce carbon dioxide and water. Then, so we had seen different types of reactions such as synthesis, combination, synthesis or combination, decomposition reaction, single displacement and double displacement. And among these reactions, some reactions are exothermic and some reactions are endothermic. So generally when a reaction takes place, there will be like either energy is absorbed or energy is released. So in general, in a chemical reaction, when energy is absorbed, it is endothermic. When energy is released, it's found to be exothermic. Right, so that is all for today's class. And second topic, second lesson, basically we had gone to the like more explanation on exothermic and endothermic reaction. So two objectives are being covered in this lesson. One is to describe the meaning of exothermic and endothermic reactions and provide examples, and second is to interpret the energy level diagram showing each type of reaction. So in an exothermic reaction, we know that the heat energy is released to the surroundings. right? So the reaction becomes hot. You can see from the diagram. So the temperature increase you can find using a thermometer. What about an endothermic reaction? Endothermic reaction means energy is absorbed, right? So in an endothermic reaction, when it takes place, suppose there is an endothermic reaction in a beaker or in a test tube, you touch the walls of the test tube, we can feel it's want to be very cold now, right? So temperature of the vessel and the contents will be falling down during an endothermic reaction. So this is a summary. Understand, in an exothermic reaction, when the reaction takes place, there is an increase in temperature. But once the reaction is over, when there is no more reactant, naturally it will go back to room temperature. Same story works for an endothermic reaction. Temperature falls down, but once the reaction is over, it will go back to room temperature. Right? So this is happening for exothermic and endothermic reaction. It will go back to room temperature. Now you should be able to list down a few examples of exothermic reactions such as combustion, neutralization, etc. Endothermic reactions such as electrolysis, photosynthesis, thermal decomposition, and so on. And some see, if I ask you, I had given you a particular like two reactants. Suppose ammonium chloride dissolved in water show that this reaction is endothermic, or cement is added to water show that this reaction is exothermic. So how will you say that the reaction is exothermic and endothermic? You have to measure some factors, right? So basically, to know whether it is exo or endo, what you need to know is temperature. How will you measure temperature? Using a thermometer. So you will measure the initial temperature of water, for example, the first reactant. Right? Note down the initial temperature. Suppose it is 25 degrees Celsius. You put the solid. If the temperature increases still continuously, right? So you have to mention specifically using a thermometer, measure the initial temperature of water, the first reactant. Then you add the second reactant slowly and measure the final temperature. If there is an increase in temperature, the reaction is found to be exothermic in nature. If the temperature falls down, the reaction is endothermic in nature. Now see, this is the enthalpy profile diagram for an exothermic and endothermic reaction. So you can make a comparison here. The only difference is in an exothermic reaction, product is at a lower level, right? And in an endothermic reaction, the product is at a higher level, right? Because see, in an exothermic reaction, energy is given out to the surroundings. So naturally, the product will be having lower energy. But in an endothermic reaction, the reactant absorbs energy for the reaction to take place. So naturally, when it goes to the product side, the energy will be higher. Now see, here you have to mention when you are plotting the graph, what you are taking on the x-axis is progress of the reaction. Time is a measure of progress of reaction. And you can take energy on y-axis. So just mark the energy of the reactant, energy of the product. So what is the difference in energy between the reactant and product? That is the energy released in an exothermic reaction. How will you calculate the energy released? The product energy minus reactant energy. So product energy is a small number, reactant energy is a big number. So when you calculate the change in energy or energy release, it's found to be negative. Then you can also find one term called activation energy, the difference between the reactant and the highest position. It's not like the reactant directly goes to the product side. All the reactants are not getting converted to the products. Only those reactants which are having some minimum amount of energy goes to the product side, right? So the minimum amount of energy that should be possessed by the reactant molecule, you can call it as activation energy. So this is a plot for exothermic reaction. Coming to endothermic reaction, the only difference is the product is at a lower level. So if they gave you in the question, like identify whether it is exo or endo, the easiest way is from the graph, you check where is the position of the product. If the product is at a higher level, endothermic. If the product is at a lower level, it is exothermic. Now, see, your reactant is having an energy, your product is having an energy. You can use the term enthalpy. Enthalpy means the total heat content, right? So here, the enthalpy change means the difference here. You can denote by using the symbol delta H. Delta stands for change. So how will you find change? Final state minus initial state, right? What is the final state? The product state. So H products minus H reactant, right? So for an exothermic reaction, the product is having lower energy, so delta H is negative. But for an endothermic reaction, the product is having higher energy. So remember, delta H is positive for endothermic and negative for exothermic, right? Then see here activation energy. So I had already explained the significance of activation energy. That's the amount of energy needed to initiate, needed to start a reaction, right? So how can you represent it? The energy of the reactant, at the same time the highest position. Remember, the activation energy is always a positive value, not a negative value. But when I told you about delta H, I mentioned specifically delta H is found to be positive for endothermic and delta H is negative for an exothermic reaction. So till now, we are able to draw the enthalpy profile diagram, right? So examples also you are already familiar, and to understand the significance of activation energy. Now in the third lesson, we were explaining about bond energy calculation. So like bond energy calculation, when a reaction takes place, reactants are going to the product side, isn't it? So like reactant side, you have to break the bonds, and the product side, the new bonds are being formed. In order to break the bond, you have to give energy. So bond breaking is endothermic. When a bond is formed, energy is found to be released, right? So bond formation is found to be exothermic in nature. So now see, you can identify an endothermic and exothermic reaction. Remember, energy is needed to break the bond, and energy is given out when a bond is formed. So for an endothermic reaction, because bond breaking is endothermic, right? The total energy needed for bond breaking should be greater than bond formation energy. Then the reaction is endothermic. If the bond formation energy is more than bond breaking energy, the reaction is found to be exothermic in nature. Now coming to the next point, what is an enthalpy change? Enthalpy change you can represent in the graphical, like we were already explaining the enthalpy profile diagram. We were marking the product energy, the enthalpy of the product minus enthalpy of the reactant. So today we will be seeing like by carrying out the numerical calculation, how to calculate delta H. As you know, the reactant side energy is given to break the bond, product side energy is given out to form the new bond. So delta H is equal to the energy taken to break the bond minus energy given out to make the bonds. So like the bond energy of the reactant minus the bond energy of the products. So one example were the decomposition of hydrogen peroxide to water and oxygen. So you calculate the bond breaking energy, you are getting 2148. Bond formation energy is 2354. The plus and minus sign indicate plus means energy is absorbed and minus means energy is released. What is delta H? You will be getting minus 206 because you got a negative value. The reaction is found to be exothermic. You will get more practice question in your classified paper 4 related to this bond energy calculation. Please proceed solving these questions in the past paper. Okay. Now, the next lesson we were explaining about the energy released by a fuel. We are already familiar with different types of fuels like oils, petrol, diesel, natural gas. Then, so we are see like for example, if I ask you petrol or diesel, which is a more efficient fuel, how will you calculate the energy released by a fuel? So today we will be covering the describe the release of heat energy by burning fuels. So a fuel is any substance that we are using as a source of energy. So normally when a fuel burns, it produces heat energy. You can use it for different purposes like driving cars to generate electricity and so on. So the amount of energy given out when 1 mole of a fuel is burned completely. 1 mole of a fuel, you call it as heat of combustion, right? So most of the cases, the energy is given out as heat. But there are very few reactions in which light is released or electrical energy is produced. The very same thing we had seen in electrochemical cells. Now, see, if you have different types of fuels, how will you say the fuel is good or bad? So, in order to say the fuel is good, the first thing is it should have high calorific value. When I told you heat of reaction, it was for 1 mole. But calorific value, we always take one. That is more convenient to calculate also. You take 1 gram of fuel and burn in oxygen. See how much energy is being released. That is found to be the calorific value. So if you have a fuel with very good calorific value, it is very efficient. Right? Produces lots of energy. So it's a good fuel. And at the same time, once the fuel burns, if it is not producing any poisonous gases, it's found to be a clean fuel or environment friendly fuel. Then also it should be available in plenty, large quantities should be available, transportation should be easy, comparatively cheap, and rate of combustion also should be balanced and moderate. So these are the qualities that we are expecting for a good fuel. Now see, you can compare the efficiency of the fuel by using a calorimeter. So this is actually the experiment using spirit burner. You can find the energy released by a fuel in the laboratory by using a spirit burner and a metal can called calorimeter. The heat energy released is used to raise the temperature of, see, you can find the spirit burner down, the water is there in the beaker, or even you can take it in a copper can. So when energy is released, absorbed by water, so temperature is increasing. Let's see the procedure. You will take a non-mass of the fuel. Suppose I ask you to compare petrol and diesel. 1 gram petrol, for example, I'm taking in the spirit burner. Right, so you have to note down the mass exactly using a weighing balance. Then afterwards, you take the fuel in the spirit burner. You also measure non-volume of water you take in a beaker or a copper can. Then at the same time, there is a thermometer you are keeping in that. Note down the initial temperature of water that you had taken in that copper can or calorimeter. Then already you noted the mass of the fuel in the spirit burner. Ignite the fuel, record the highest temperature. Right, if you want to compare with other fuel, repeat the same experiment with the same amount of the other fuel. Then what all things to be the same? You can keep the same volume of water in the beaker, almost same initial temperature. Distance between the copper can and spirit burner also should be the same. Right, compare the highest temperature. Suppose that you calculate the temperature difference for both the fuels. Suppose for petrol, I got a temperature difference 30 degree. And for diesel, I'm getting a temperature difference 20 degree. So I can say that the first one has higher difference in temperature. So it's found to be a very efficient fuel than the other. Understood. So this is a procedure to compare the efficiency of the fuel. So like always for fair comparison, when you repeat for the other fuel, remember what are the factors to be kept constant, right? So always remember any heating experiment, always if they ask you what is the source of error, it is the unwanted heat loss to the surroundings. So how can you minimize it? See, your beaker is open. You can cover with a lid or you can insulate the sides of the beaker, right? Or even like normal beaker, change the normal beaker to copper can, because copper is a good thermal conductor, so it absorbs the whole energy that is coming after the combustion of fuels. And moreover, you can repeat the experiment so that it will become more reliable. Now next is a coffee cup calorimeter. Only for combustion reaction you proceed with spirit burner. Non-combustion reaction, the normal coffee cup that is made up of polystyrene is preferred. Why are we preferring polystyrene? It's a very good thermal insulator. And if they ask you how to improve the accuracy, you can keep a lid at the top, right? So this is for non-combustion reaction. Then, so the next topic, the fifth lesson, we were discussing about the different types of fuels. We are already familiar with the different petroleum resources, hydrogen as a fuel, then radioactive like uranium as a fuel. So let's see what are the advantages, what are the disadvantages of each categories of fuels. Now see, the objectives describe the release of heat energy by burning fuels, radioactive isotopes, advantage, and hydrogen as a fuel, advantages and disadvantages of using these fuels. So generally when I say the term fuel, it is a substance that is used as a source of energy. It may be solid, liquid, gas, anything. Right, some fuels upon burning produces energy, some are not. Especially fossil fuels undergo combustion reaction. And whatever is the type of fuel you are taking, it has its own pros and cons. Advantages are there, disadvantages are there. When you go with the fossil fuels, basically they are hydrocarbons, right? So upon burning, it produces carbon dioxide and water. Upon burning in excess oxygen, that means complete combustion. Right. So fossil fuels basically they are formed in the geological past when the remains of living organism. It will take millions of years for this petroleum deposit to be formed. Right. So it's not a very fast process. And what are the advantages? Basically, it produces heat energy that we can use for domestic purposes. Then in industries, we are using it. You also use to generate electricity. What is the disadvantages? It produces carbon dioxide. Carbon dioxide is a greenhouse gas which has a capacity to absorb the solar radiation, which can lead to the increase in average temperature of the earth, which we call as global warming. So the next is hydrogen. No doubt hydrogen is a promising fuel. It bonds in oxygen to form water. You know, like probably 50-60 years back itself, NASA and all, they were using hydrogen as a fuel in rockets and spaceships basically. So it is used as a rocket fuel, and now some countries are having, just like our petrol pumps, they are having hydrogen pumps in some countries. Hydrogen, when we are using, there are many advantages and also disadvantages are there. And no doubt, if we can overcome all these disadvantages, hydrogen is the best, we can say, promising fuel for the future. What are the advantages of using hydrogen as a fuel? It will not cause any pollution because upon burning, it produces only water. So it's going to be quite environment friendly fuel. And heat of combustion or calorific values want to be very high, right? So it produces lots of heat energy. Disadvantages, of course, is difficult to store and expensive to produce, and there are some safety issues associated with handling this gas. So these are the disadvantages. When you go with the nuclear fuels, basically we learned about isotopes in the second chapter. So isotopes, as you know, like some isotopes are found to be radioisotopes, unstable nuclei they are having. So they can undergo nuclear fission reaction. So one such isotope is uranium-235. It's a very good source of energy. And you know the amount of energy that you are getting from uranium is 2.5 million times more than the one that you are getting from burning of coal. So it's found to be like producing tremendous quantities of energy. But see, when you keep a radioactive material, all in a sudden it is not going to break down producing this much energy. There are some conditions, and not all the nuclei can undergo this one. There are some, like only very few radioactive isotopes can undergo this sort of nuclear fission reaction. But remember, nuclear fuels, we are not going to burn it, right? In place of that, the atoms are broken down. How are they breaking it down to different nuclei? When high energy neutrons are bombarding on this unstable nucleus, it is breaking down to smaller atoms such as lanthanum and so on. So like sometimes even after breaking it down, you will be getting a new radioactive materials. The products are also found to be radioactive. The advantage, of course, it is not producing any carbon dioxide or any poisonous gases such as oxides of sulfur or oxides of nitrogen, which can ultimately lead to acid rain. Moreover, very small quantity is required to produce huge quantities of energy. Of course, there are many disadvantages. The problem is in disposing these radioactive isotopes. Like there is a possibility that accident can cause the release of these harmful radioactive materials, and moreover, it is very expensive also, even if small quantities are required. Then the sixth lesson, actually, we were explaining about like some additional points that they normally ask in experiments related to this energy changes, and there will be a lots of question in your paper 6, like planning question and graphical evaluation, like plotting the graph and identifying the values from that. Okay, so just keep in mind a few additional points, like what is the advantage of using a polystyrene cup? Of course, it will be like to reduce the heat loss. And again, if they ask you what improvement you can give, you can keep a lid so that there will not be any heat loss to the surroundings from the top. Then when you are doing a spirit burner experiment, why do you prefer a copper calorimeter? Copper is a good conductor of heat, and also it can, like, whatever is being absorbed, whatever is being released from the fuel is efficiently conducted to water. Then when you are using different solids in the same polystyrene cup, if you do the experiment, of course you have to rinse the polystyrene cup. That is only to make it clean, right? And temperature will be remaining the same when excess of the solid is added, so that indicates there is no further dissolution in the solvent. And always continuous stirring using a thermometer. Why are we stirring continuously? Of course, it is ensuring the heat is evenly distributed throughout the whole solution. Then if 4 gram of a solid produces 14 degree, 2 gram, same volume of water, half temperature rise. So there will be some calculation of this sort. And if they are asking you, like, if there is one anomalous point or inaccurate point, how can you avoid this one? How can you make it more accurate? Take more readings. And so if you are taking like 10 readings and one is an anomalous point, that will not affect the whole experiment. But suppose I had taken only 4 readings and one is wrong, your experiment, your graph also, like, it will be having lots of errors. And most of the time displacement reactions are exothermic. Greater the difference in reactivity, greater is the temperature rise. Then there are a few things to be remembered, like what is a source of error, what is the improvement. For example, if the in the experiment, if they are using measuring cylinder to transfer liquid, if they ask you how can you improve it, use a pipette or burette, because you know measuring cylinder is for faster addition, burette and pipette is for accurate addition. Then so that is all about the topic. So like in 6 lessons, the topic has been divided into 6 parts, 6 lessons, and we had successfully completed the project. And the homework, classified paper 4, all of you are having the classified paper 4. Take the chapter on energy changes, solve question related to the topic, and choose your paper 6. Or if you don't have the paper 6, a graph question and planning questions will be uploaded in your MIS portal. So definitely this will help you to emphasize the learned concept. You will get a better understanding, and also you will be familiar with the way they are asking questions for your IGCSE exam. So good luck everyone, and thank you.